Hello, Berlin. Hello, everybody. Thanks very much for coming today to this webinar. So I am Diego speaking, the one on the left, and also my colleague Luis on the right of the picture. He's also helping with questions, and he will be also connected to help. So today we are going to talk about some of the new features. If you already know Conan and you have interacted with us, you know that we try to listen a lot of, especially on GitHub issues and also emails. We get a lot of feedback, and we continuously improve the tool. So today I would like to introduce some of these features that sometimes are overlooked, or the changelog doesn't explain them very well. So let's start straight ahead with how to create packages with Conan. Of course, this is a webinar of a series of webinars we have been doing. We assume that you already know a little bit about Conan. I try to explain most of things, but you should know something. So if you want more information, you probably want to go first to conan.io, or also you can find the previous webinars in the JFrog YouTube channel. So okay, so let's see how to create packages from existing code. So the first important thing here is that we have changed the default command to create packages. So to create packages, now the command is Conan create. Some of you might know from the past that the command was called test package, but we really think that Conan create is more intuitive, and also it is doing different things. So let me explain. In real code, I'm going to show you how to create a package for a simple library. So here I have the hello library. Okay, I have a source folder with two source files. The first is a header with a declaration of my hello function. You can see that it has things for being able to create a shared library, a DLL in Windows 2. And here we have the source code that will just output a message on my screen that will be different for 64 bits and 32 bits architecture. So this is my hello method, very simple. And to build this into a library, I'm using the CMake build system. It is not mandatory. You can use any build system, but in this case, I'm going to use CMake. Here you can see it is very simple. Just add library with my source file, hello CPP, and I'm going to create a hello library. So this is my source code. And to create a package from this source code, I'm going to use this recipe here. A recipe is a Python script. It's a conanfile.py Python script. First, I forgot about this. Let me. Okay, so this is my Python script to create packages for hello. Here you can see that I have my settings and my options. If I change any of these, I will get a different binary. So if I change my compiler, I will get a different binary. If I build in a static, I will get a different binary. If I build in dynamic library, I will have a different binary. Okay, then I will have the build method here. I'm going to use CMake to build the binaries for my source code. It's very simple stuff. You can find lots of information in the Conan site. Here I will package. I will get the artifacts, both the headers and the libraries, to create a final package. And this will define my consumers that they have to link with the hello library. So this is everything I need to create a package. So I'm going to show you Conan create user testing. So this is going to create in my computer, in my local Conan cache. Oh, sorry, I haven't changed to the hello folder. Let's try again. Okay. So here you can see that I'm going to use, I'm in Windows, by the way, so I'm going to use Visual Studio 2017. Okay, now Conan is able to detect and to build with Visual Studio it introduced some VSware application to detect it and some complicated, but Conan is already able to manage them. So it's up to date with the Visual Studio compiler. So now we can see that we have here our package. It has created it and it has packaged it. We also can see a warning here. We will check which warning is this. Of course, I can create the package also for a different architecture. For example, I can build the package instead of the default that is going to be 64 bits. I can create a package for 32 bits, and the process will be also the same. So several things have improved here. For example, the first one is that I don't need anymore the name and the version of the package. So if I want to remove them from my Conan recipe, it is perfectly fine. Okay, I can remove them. And then instead of typing just Conan create and the user and channel, I can just type dynamically the name and the version. This can be very handy. For example, if I'm using the same recipe to package different versions, because the recipe is always the same, it doesn't change, I don't need to hard code the version into the recipe itself. I can provide it in the command line. So I can do this, and I'm also going to specify that now I want to build the hello library as a dynamic library for 32 bits in this case. Okay, now it's building the dynamic library again. No, I think. Oh, sorry. Yeah, it was my mistake here because I added. It's not a setting; it is an option. So I have to provide the option to build the dynamic library. So let's try again. Okay, and while it builds, let's check a new thing. So now testing the package is optional. You can provide it, or you cannot, or you don't need it at all. In this case, I have here a test package 2 folder that is not being used by default because the name has changed. If I rename it to test package, then it will test the just created package here. So the contents of the test package is the same as usual. It's just a source file, a build file, and a Conan file. The novelty here is that we don't need here to declare requirements anymore. So in the past, in the test package, you need a requirement to test the package that is being built. So you have to hard code here the name of the version of the package being tested. Now it is not necessary anymore. You can do it without it. So if we want to test the package that we are creating, now here we can see that we have created the package for a dynamic library, and here we can see that it's packaged in the DLL. So if we want this, and we want to create like a dynamic library for 64 bits, and I also want to test the package that I'm creating, I can provide the test folder, and I will specify that I'm going to use test package 2 folder to test the package I'm going to create. So the process will be the same, but this time it is going it's not only building the package, but it's also building an application that will use the package to test that and to check that the package is correct and it is working, and you can link with it and you can use it. So now the package has been created, and now it is building the test application inside the test package 2 folder. As a final step, it will launch the application. So here we can see the output of the test application. So everything seems to be working here. Okay, so we knew about one command that was called Conan search. And if we specify Conan search and a given package reference, we can see now that we have 4 binaries for different configurations: dynamic, static, 32, 64 bits. But this information is sometimes difficult to process and everything. So if we have many binaries and we have to check them all at the same time, there is a new feature that is very handy for these things. It's called Conan search. And if we provide table, argument, and an HTML file, it will output an HTML file with this. Okay, so here we can see that I have 4 packages, all for Windows Visual Studio 15. Okay, and I can check the IDs of the different packages, and I can also check which of the binaries for these configurations is outdated for the recipe. Why this one is yellow here? Because if you remember, I modified the recipe. When I was telling you that you can remove the name and the version of the recipe, I was modifying the recipe. So now it knows that this package here was built with a different recipe because I modified it. So this is warning me that I probably want to rebuild my package with the up-to-date recipe. In this case, it's not necessary because the change was obvious. I just removed the name, so the binary is not going to change. But in any case, it is warning you that you probably should consider to rebuild this binary because the recipe has changed. So this is a very convenient a new feature that we have recently introduced. Another one also regarding information is the get command. Many times we want to know things about a recipe. For example, which are the options of this recipe? In this case, imagine that I'm just using the hello library, the hello package. Okay, but I haven't created it myself. Probably the hello package is in a remote, it's in Conan Center. So if you want to inspect packages, it's now very easy with the Conan get command. This can be applied to many different things. This can be applied, for example, to packages. And if you apply it like this, you will get the package recipe. It works exactly the same for local cache and also for remotes. So you can inspect remote packages with this command too, just specifying the remote. So in this case, you can check, okay, so here I have these settings, these options of this package, so you know what the package is doing. Just having a look at the recipe. Okay, so now you see that I've been creating packages, and I have been providing settings on the command line, like changing the architecture, 32 bits, 64 bits, and so on. This is not the typical recommended flow. So for real production usage, we recommend the use of profiles. Okay, so with profiles, we have the profile command to manage them. So we can list the existing profiles in our computer, and we can see there is just one. This default profile is the configuration that used to be in Conan.conf. So in Conan.conf, there was a section using your default settings. Now it is not there anymore. It is in this default profile. You can inspect profiles with the Conan profile show, and then the name of the profile. Okay, and you will see that my default profile is Windows, 64 bits, Visual Studio 15, and release. Okay, this is my default profile. There are new commands to help manage profiles dynamically if you want. Profiles are just text files, so you can just write them if you want. But if you want to interactively create them or modify them, you can too. For example, I'm going to create a new profile, Conan profile new, that I'm going to call Visual Studio 14. And I'm going to ask Conan to detect my defaults. So now I have 2 profiles. Okay, and if I show my Conan profile show Visual Studio 14, I will check that it has my defaults, my detected defaults, and it detected my latest Visual Studio. But I can easily change that. Conan profile, update, settings, compiler version equal 14 in my Visual Studio 14 profile. So now my profile has changed and it's ready to be used. I can Conan create hello user testing, and instead of providing my settings in the command line, I will just specify the profile. So now I'm going to use Visual Studio 14 to build a binary. Here we are. So if I search now, I will see that now I have another row in my table for Visual Studio 14. And I created just this binary for this configuration for Visual Studio 14. Okay, this is quite good, but still not the best thing, because if I want to share for example, my profiles, I want to share them with my team usually, and we want to make sure that we have all of us have the same profile. But what about the remotes? For example, this is like a clean installation of Conan. I can list my remotes. I can say, okay, I want to check my remotes. And I will have two of them. These are the two default remotes that comes with Conan. Okay, but now I don't want them. I mean, I'm using Conan in my company. I want to use my own remotes, and I want all my developers to use the same remote. How can we manage this? So now this can be done automatically. So for example, you can set up a Git repository, and you can put their information. You can also put it in a zip file. So instead of a Git repository, you can use a zip file with the same information, and it will work. In this case, I'm going to have a configuration here. It's in GitHub, and there are a couple of things in this configuration. I have a remotes file that is going to specify my local remote that is going to be an Artifactory instance. Okay, and I also have a profiles with a profile here for Raspberry Pi, Linux, GCC 4.6, and architecture IRM v7. And here the cross compilers that I need to use for this Raspberry Pi. So this is a new profile that I don't have installed in my machine. So all I need to get all this configuration and synchronize with my team is the new command. Sorry, let me copy this URL. So to get all of these, I need Conan config install, and then specify like my Git repo. If I do this, it will get the information from the repo, and it will install the information. So now you can check my list of remotes will be just one remote, the remote that has been specified by the configuration. And if I check my profiles, for example, now I have installed my profile for the Raspberry Pi that is ready to be used. So I can just Conan. I'm going to create with the Raspberry Pi GCC 4.6 profile, and now it's going to build the Hello library. Here you can see it's using GCC 4.6. And we are done. Okay. If we check out again our table of binaries, we will see that we have another row, in this case for Linux, GCC 4.6, and ARM v7 architecture. And I have new binary for this architecture here. So the Conan config install command is very powerful because it can do many things. It can do remotes that will be basically overridden. If you have remotes that you are not specifying by the remote configuration, they will be removed because you don't want your developers to connect to external remotes, for example. So they can be removed. Profiles that will be added. So it will not remove my custom profiles that I'm using locally, but it will override if they have the same name, or it will add new profiles as necessary. Also the settings YAML file that specify all the topology of my settings, my compilers, my architectures, all the information I need for my different targets and platforms can also be config installed. The Conan.conf file is merged. So if there are some fields that are not specified by the remote configuration, they will be left as is. They will not be modified. But if those fields in Conan.conf are defined by the remote configuration, they will be used, those of the remote. Also, any other files that are in the remote configuration, they will be copied to the Conan installation. That can be useful. For example, if you have a PyLint resource file with the syntax for linting, for the style of the recipes yourself, you can also distribute it. Okay. Maybe some of you have the question, hey, but if I do a Conan config install, it's going to wipe my own configuration that I'm doing to test things. Okay, yes, that is fine. This is what you want with Conan config install. If you want to have your own environment for playing around and you want to connect to Conan Central and wherever, you can do it very easily. With Conan User Home, you can have many different Conan environments in parallel, and each one will have their own cache with their own settings, with their own configuration. Everything will be independent. So you can have your instance, your Conan instance, let's say with Conan User Home for your purposes, and you can have your default Conan installation for the company, for example. And by the way, the URL is only necessary the first time you run it. So if I just type Conan config install, now the URL that I used the first time, it is already stored in the configuration. So it will be used again. So developers, when they want to synchronize with the upstream configuration of the team of the company, they just have to type Conan config install, and they will get the new configuration in their machines. Okay, I think this is a very cool feature. So now I'm going to move to explain a little bit about the local flow. It's something that sometimes many people, they don't know, is that you can fully develop your packages, not in the local cache, but in your user folder. So I'm going to move here to an app application. I will show you very quickly the source code of the app. Here, this is our main function for our application. It's just calling the hello function twice. Okay, this is all it does. And then the CMake list to build this application is just defining an executable from the app.cpp file and saying that, hey, you have to link with the installed Conan libraries. Okay, so the source code is very simple. And now we are going to create a package for this application here, and we are going to do it locally. Okay, so here we can see the important things here is that we have our requires, because our applications actually depends on the hello library. The build method is exactly the same, and the package method in this case, it only has to package an application, the application, not need to package, for example, headers or anything like that, just the application. So what I'm going to do is, okay, I'm going to create a build folder. I'm going to move to that build folder. Okay, so if I want to build my application, I need my dependencies. So I'm going to install my dependencies. So with the Conan install, I will install my dependencies locally. And now it was very fast because I already built the hello library like a few minutes ago. but otherwise it will try to build it, or it will retrieve the hello library from our remote server, and it will be installed in my machine, and it will generate my Conan build info. And now I can just also build this locally. So for this, I could just write CMake, and I could say, hey, CMake dot -g, like, but, and then open my Visual Studio solution and click build. But with the Conan build local command, I can do it also very easily in one step. So it's very convenient, at least for the first time, to bootstrap the thing. So here we can see that it has created the project. So we can see our Visual Studio solution. If I want to open it and to build from it and everything, it will be fine. You can just open the solution and go there. Okay. Also, you can see that I have built my app here. If I execute my app, it will output twice because it had 2 calls to the hello function. So it's working. I can now, everything is local in my user folder. I haven't touched my Conan local cache at all. So if I want to create a package from this application that I have local now, I can do it directly. It doesn't require to build in the local cache at all. So first step is just I need to export the recipe. So now this command export is copying the package recipe into the local cache. And then I can just, okay, tell Conan with the command Conan package files, I can say, hey, I already have binaries for this. You don't need to rebuild them from sources because I already built them. So it's going to specify the, sorry, 0.1 user testing. And I have to tell, hey, I have built it here in my current folder. And that's it. And I have created a package like this. It's just doing a copy. So this flow here is very convenient because if I'm working on several packages simultaneously, I can do it. I will be here. I can have my Visual Studio solution open. And when I want this to be available for the rest of the packages that might depend on them, I will just do a Conan package files, and my binaries will be copied to the Conan cache. And from there, all the other packages can link with them and can use with the latest version that was just created. So I can get the benefits of incremental compilation and incremental linking because I don't have to do a clean build again and again in the local cache. I'm working with my environment in my user folder, and everything is fast. Everything is at the user, and I only have to copy the binaries. That will be done with this line here. This line here can also typically be very easily automated in your IDE. So if you can, if you can have some possibilities of a post build step, you can add this line to your post build step, and it will be automated for you. So okay, now I would like to talk about a concept that is been asked many times. Is it possible to do releases with Conan, to distribute your final application with Conan? Of course, if you want to create your own Debian packages or any other kind of system packages, you can do it. You can just get the binaries with imports, for example, and you can then create your system packages. But now I'm going to show you a way how to do also releases with Conan. So let me show you. Okay, so here I have a recipe, a package recipe that I have created to do releases, to release my application, and it has several advantages. So first thing we should note here is that I have removed some of the settings. For example, in this case, I'm not interested in the compiler or compiler version or the build type. I just want to create releases for different operating systems and for different architectures. Okay? But I still have one option because I want to create releases that will release my application statically linked or dynamically linked. In that case, it will also have to redistribute the dynamic library. Okay? Then here is a different concept. Now I'm going to use build requires. Why? Because to create this is a runtime package. You only need the app package and the hello package when you are building this one. Okay, so this is a build requirement. It's something that you only require to build the binary for this. Okay, so instead of using a normal require, I'm going to use a build requirement. I will show you later what is the advantage of this. Then I'm using different methods. The configure method here is just propagating my options. So if I want an app run package that is dynamic, I will tell that it's going to use the hello dynamic library. And also the opposite is if I want to the app run package to be statically linked, also the hello library that I'm going to use is the static library. Okay. So now to build my app run package, I'm going to use the imports feature. The imports feature is just a copy. It's a copy of files from your dependencies. In this case, I'm telling Conan, hey, when you are building this app run package, then you have to copy all the DLLs and all the X's from your dependencies and from the whole tree, the whole graph of your dependencies. So please copy all the DLLs and please copy all the X's from all the dependencies, that is app and hello, and copy them. And copy them to the bin local folder. Here, I'm applying a trick in the build folder. Why? Because actually the default Conan behavior for imports is, okay, when you have to build the package, you will import, you will copy your DLLs and X's from your dependencies, and then Conan will remove them automatically. Why? Because by default, Conan doesn't want to package again and again your dependencies because they are already packaged in your transitive dependency graph. Okay, so in this case, we have to override this behavior. So I'm just creating a local copy of these artifacts. And then finally, in my package method, I'm going to just package this copy of the artifacts. This is a bit complicated user interface. There is already an improvement. There's a GitHub issue to improve this behavior, so it would be easier. Just keep in mind that what it's doing is copying the DLLs and the X's from your dependencies and packaging them. So in this case, the app run will contain artifacts from both app, the exe in this case, and also from the hello package, the DLL in this case. Okay, so this is what I need to create a runtime package. So I can just Conan create user testing. I'm going to specify, because I haven't built all the binaries for app. So I'm going to specify here, hey, if you need something that I haven't built the binary, please build it from sources. So I can Conan create. In this case, it was fast. And now I can create different versions. I can create also the one for 32 bits. And I'm building different runtime packages. In this case, it is building app from sources because it doesn't have this configuration. Typically, the app package would have already been built by continuous integration or whatever. Now I'm going to specify also that I want to create dynamic distribution. So in this case, you can see that it is packaging. The app run is packaging both the dynamic library and the appx file. And finally, I could do also the 64 bits architecture in its dynamic flavor. Okay, here we go. So, okay, so now I have a runtime package. So I'm going to upload this package to my remote. Yes. Wow. Sorry, let's try again. Let me check if my instance is running. Yeah, everything looks good. Sorry. No, I don't know what I did. Probably was typing wrong. So I uploaded all these 4 runtime packages, and we can see them here in my Artifactory server. And I will check that I have a Windows 64 bits dynamic, 32 bits static, 64 bits static, and 32 bits dynamic. I have my runtime packages here. And you can see that they contain the application, the dynamic library, and nothing else. Okay, so now I can remove absolutely everything from my local cache. So I have removed my Hello library, my app package too. And what I'm going to do is I'm going to install just the runtime. So I can do that with Conan install app run. Okay, I could do that. But let me introduce a new concept too that is very useful. Is the virtual environments generators. So there is a concept here that, okay, if I install this package, it will have binaries, but they will be inside my local cache. Okay, how can I use them easily? So you can use a generator that is called the virtual run environment. So I will install this. Sorry, my mistake. I was mistyping this. Okay, so the first thing we see here is that it only retrieved app run. It didn't need to retrieve at all app package or hello package. Why? Because I already have the binary, and those packages are only necessary to build this binary. As I have the pre-built binary already, I don't need those dependencies at all. So when I install this runtime, I install just the runtime, not necessary to do anything else. And now I will show you that I can execute the runtime. If I type app, it will not find the app. But as you can read in my terminal, it has created different files. I'm going to show you the contents of the activate run file. And here you will see that this file is adding this folder for me to the path. It can also add to the to other paths for Mac OS or Linux, to the LD library path, for example. In this case, in Windows, it is enough to add to the system path. Okay, so then if I activate this, I am ready good to run the app. And this is my app running. So this is very convenient because now I can manage the installation, the release of my final application without having to bring the whole dependency graph. And I have the advantages of using Conan. So I can manage easily to distribute to different platforms, different architectures, different types of deployments like static and dynamic. And I can have all of them in my Conan server, in this case in Artifactory, and I can see what I'm deploying is very easily. And deploying will be always the same. I will be in my final machine that is going to run the application, Conan install the runtime, activate the path, so it's found, and then launch the application. So fairly easy. By the way, there are other environments that might be useful for you. For example, a virtual environment is used for defining environments with your custom environment variables. So your packages can define environment variables. If you use the virtual environments, you will use those environment variables in your environment. Also, the virtual build environment. This will inject as environment variables information for building. So like include directories, library directories, library names, all the information that typically Makefiles or other tools need, they can be added to the environment. So it might be possible to build something that has Conan dependencies without modifying the Makefiles at all, because it will get the information for the environment. You can achieve that with the virtual build environment. Okay, and finally, to finish this webinar, I would like to introduce the Conan alias feature. So for that, the concept here is about updating your dependencies. So imagine that we have here this dependency graph, okay, and at the top we have a library A version 1.0.0. And then a new version is released, and it gets some improvements, and lib_a 1.0.1 is released. So we have this dependency graph. But the rest of the application is still using the old lib_a 1.0.0. So how can we make the whole application to use the new changes from 1.0.1? So there are different strategies for this. One would be the explicit, that just hard coding the changes. Is very effective. It can be a bit slow, but is very safe and explicit, and is something that many people are doing successfully. You can use version ranges. You can use expressions. That would be updating on the user side. So it will be the consumer who is specifying which updates it allows. Okay, but this can be sometimes problematic. It can be slow for a lot of, if you have hundreds and hundreds of versions. And also it blocks if, for example, version 1.0.184 is released, and that package has already this version range expression, it won't update, okay? There are other way that is using overriding. And finally, is the server side, is the package publisher a way to update dependencies, is the Conan alias. So the explicit way would be this one. Will be okay, we have lib_a 1.0.1, and then we will create a new version for lib_b. That is we are going to bump lib_b version 1 to 1.0.1, and inside it will use explicitly the requirement to lib_a 1.0.1, and then we will keep propagating the changes down the dependency graph, and everything will be explicit. It will be, we will be creating everything. It works. This approach works. It requires some methodology, but it works pretty well. You can also do dependency overriding. So instead of modifying the dependencies in the whole dependency graph, you can take the downstream, in this case, the final application, and you can do an override. You can say, hey, I want to use liba 101 in my whole dependency graph. And this is going to be an override. So, and this is specified in the final app. So this is the idea. The app defines, hey, I want lib 101, and that will be propagated upstream. And the override keyword that we are using is to avoid injecting a new edge. So we don't want this. We don't want the app package to depend directly on liba, because that's not true. It doesn't depend. We just want this, and this is what we manage with the override dependency type. And finally, we have the alias. The alias is just like a symlink. It's something that the package creator introduced, and it's just another name for a library. In this case, the package creator that is packaging liba can, for example, create an alias. It can call it liba10set, and it can point this alias to any version they want. So the consumers, in this case libp, it has to require only liba10set, and it will be totally transparent for them. Actually, this liba10set is not in the dependency graph at all. Once the dependency graph is resolved, libp will see that it's requiring liba101, even if it declared 10set. Okay, so it's just like a symlink or a totally replacement of the package. Defining alias is very simple. So it can do with the Conan alias command. It will specify the name you want to use. For example, the latest alias. The latest alias user testing will be pointing, in this case, to 10. Okay, that's it. So I can just Conan upload. Yes. Yes. Okay, so I can totally remove my local cache now. There's nothing here. By the way, if you want to inspect an alias, it's just another recipe. It's very simple. The Conan alias command is just a helper, but if you want to check the recipe, you can check. It will be Conan get up run latest user testing. I'm going to inspect the recipe directly in my remote. So this is my alias recipe. It is just a package recipe with just one field here, one attribute that will be the alias that will be pointing to the one that we are resolving. So now that I have nothing in my local cache, I can perfectly install Conan install my alias. I will get the alias here, and I will tell the system to generate, as before, virtual run environment. Perfect. So if we check what we got here, the activate run that, here we will see that it's actually resolving to uprun 10. It is not using latest at all. Latest is not a package at all. So it will resolve to 10. And the result will be exactly the same. We activate the environment, and then we can run the application. Okay, so with this, I finished my presentation because I wanted also to leave some time for questions. So I'm going to check now the question. Okay, I can see that there are 3 of them. Okay, so the question here is right now when updating from a Git repo, I guess you're talking about a Conan config install command, you replace it remotes, okay, but added a new profile. Is there a reason for this inconsistency? Yes. The behavior is something that we have thought about it. Remotes is something that is quite critical. You don't want developers to connect by accident to a given remote, okay? So the remotes will be those that are defining the configuration. As is, if you have any other remotes, they will be removed, okay? Because this is safety critical. You do and if you remember, if you do a Conan config install and you don't specify a given remote, it will try your remotes one by one until it finds the package you are looking for, okay? So this can be a security concern. So you want to make sure your developers are only using the remotes you want. And so it will replace remotes and it will remove remotes that are not declared in the configuration. On the other hand, profiles are totally harmless. They are local to the user machine. They will not be used at all unless they are explicitly declared. So the user has to tell, hey, Conan, create profile, and then use this profile. So that will be totally harmless. There is no something wrong that can be there. And if the user, they want to have a profile, for example, for debugging with debug type that is not distributed as the default profiles from the team, because the team is just caring about the release or the production profiles they are using. Those are the ones that are like official for the team. Users, they can have their own profiles for debugging, for profiling, for whatever they want, or for special architectures they are trying and they are not yet official. So in that sense, profiles can be added safely. Remotes is critical to replace them. Okay, I can. Let's check next question. Okay, so how do you debug code from Conan packages? Is it possible to download sources used for particular Conan package version? Same questions about debug symbols. Okay, yeah, so if you want to debug code from Conan packages, your packages has to take this into account. So typically package method from your package recipe could be something like, hey, if self settings build type equal debug, then copy also the sources, copy also the CPPs into the package, because you will need them to debug. The same for if you're in Visual Studio, for example, you want to package your PTBs files, because they will be the ones that are packaging, that will containing the information. So so instead of using like the original sources, the package has to create the source package. It will be the similar concept like the source packages you can also get from apt-get, for example. So you will have a package for the sources. If you want to debug your dependencies, you should package your sources too, of course, only in the debug type of the package. If you remember, packages are different for different settings. So the release type won't have the sources at all, and the debug type of the package, it can contain the sources. So there will be something typical also. But it requires, right now, it requires some effort from the package creators to allow packages to be debugged. Okay. Okay. Let me check. Questions are moving. Okay. Yeah. Okay. So there is already a way to set requirements that is needed at build step. Is there a way to set dependency that is needed only when package is used? For instance, if I use SDL and load it dynamically, I do not need binaries nor headers when I build my package, but user will definitely need the lib SDL .so file. So if I understand correctly this issue, this will be a normal requirement of a runtime package. So in the example that I've proposed a few minutes ago, I was creating a runtime package with all the information from the dependency graph, and I was copying both the dynamic libraries and the executables in the same package. But if you want to have a runtime package with a dynamic library, you can do it too. You can have that package, and it will be a runtime dependency. So in this case, I guess it will be just a normal requirement of another package that is a runtime package. Because on the other hand, I mean, Conan is mainly a package manager for developers. That's true. So you can do runtime packages, but the main purpose is for developers. So if you want to use the package, let's say in the build, but it's not the case because libSDL. So never mind. I think it will be just a normal requirement of a package that is a runtime. I'm not sure if this answer the questions. If the poster of the question wants more detail, also because we are also running out of time, please feel free to send us an email or whatever to follow up, and we could discuss this further. Okay, and I think we might be finishing. I don't know if there's another question. Just in time, maybe Pearl now want to say something, want to say goodbye. But meanwhile,
okay. Thank you everyone for joining the webinar. We're going to work on sending the recording out, but of course, if you have any questions, please do email Diego. I'm pretty sure your email diegor@jfrog.com. If not, you can always email webinars@jfrog.com. And we're also looking for Conan developer advocates. So if you're interested, please shoot an email as well. And we look forward to seeing you on the next webinar. Thank you, everybody. Have a great one. Bye-bye.
Thank you.